LoRAShear, efficient large language model, structured pruning and knowledge recovery. Large language models, LLMs, have transformed the landscape of artificial intelligence, while their enormous size presents significant challenges in terms of computational costs. We introduce LoRAShear, a novel efficient approach to structurally prune LLMs and recover knowledge. Given general LLMs, LoRAShear first creates the dependency graphs to discover minimally removable structures and analyze the knowledge distribution. It then proceeds progressive structured pruning on LoRA adapters and enables inherent knowledge transfer to better preserve the information in the redundant structures. To recover the lost knowledge during pruning, LoRAShear meticulously studies and proposes a dynamic fine-tuning schemes with dynamic data adapters to effectively narrow down the performance gap to the full models. Numerical results demonstrate that by only using one GPU within a couple of GPU days, LoRAShear effectively reduced footprint of LLMs by 20% with only 1.0% performance degradation and significantly outperforms state-of-the-arts. The source code will be available at the project's website. MM-VID Advancing Video Understanding with GPT-4v ision. We present MM-VID, an integrated system that harnesses the capabilities of GPT-4v, combined with specialized tools in vision, audio, and speech, to facilitate advanced video understanding. MM-VID is designed to address the challenges posed by long-form videos and intricate tasks, such as reasoning within hour-long content and grasping storylines spanning multiple episodes. MM-VID uses a video-to-script generation with GPT-4v to transcribe multimodal elements into a long textual script. The generated script details character movements, actions, expressions, and dialogues, paving the way for large language models, LLMs, to achieve video understanding. This enables advanced capabilities, including audio description, character identification, and multimodal high-level comprehension. Experimental results demonstrate the effectiveness of MM-VID in handling distinct video genres with various video lengths. Additionally, we showcase its potential when applied to interactive environments, such as video games and graphic user interfaces. VideoCrafter 1. Open diffusion models for high-quality video generation. Video generation has increasingly gained interest in both academia and industry. Although commercial tools can generate plausible videos, there is a limited number of open-source models available for researchers and engineers. In this work, we introduce two diffusion models for high-quality video generation, namely text-to-video, T2V, and image-to-video, I2V models. T2V models synthesize a video based on a given text input, while I2V models incorporate an additional image input. Our proposed T2V model can generate realistic and cinematic quality videos with a resolution of 1024 by 576, outperforming other open-source T2V models in terms of quality. The I2V model is designed to produce videos that strictly adhere to the content of the provided reference image, preserving its content, structure, and style. This model is the first open-source I2V foundation model capable of transforming a given image into a video clip while maintaining content preservation constraints. We believe that these open-source video generation models will contribute significantly to the technological advancements within the community. Personalized distillation, empowering open-sourced LLMs with adaptive learning for code generation. With the rise of powerful closed-sourced LLMs, ChatGPT, GPT-4, there are increasing interests in distilling the capabilities of closed-sourced LLMs to smaller open-sourced LLMs. Previous distillation methods usually prompt ChatGPT to generate a set of instructions and answers for the student model to learn. However, such standard distillation approach neglects the merits and conditions of the student model. Inspired by modern teaching principles, we design a personalized distillation process in which the student attempts to solve a task first, then the teacher provides an adaptive refinement for the student to improve. Instead of feeding the student with teachers prior, personalized distillation enables personalized learning for the student model. As it only learns on examples it makes mistakes upon and learns to improve its own solution. On code generation, personalized distillation consistently outperforms standard distillation with only 1/3 of the data, with only 2.53K personalized examples that incur a data collection cost of $4 or $6. We boost CodeGen Mono 16B by 7% to achieve 36.4% pass at 1, and StarCoder by 12.2% to achieve 45.8% pass at 1 on Human Evil. Skywork, a more open bilingual foundation model. In this technical report we present Skywork 13B, a family of large language models, LLMs, trained on a corpus of over 3.2 trillion tokens drawn from both English and Chinese texts. This bilingual foundation model is the most extensively trained and openly published LLMs of comparable size to date. We introduce a two-stage training methodology using a segmented corpus, targeting general-purpose training and then domain-specific enhancement training, respectively. We show that our model not only excels on popular benchmarks, but also achieves state-of-the-art performance in Chinese language modeling on diverse domains. Furthermore, we propose a novel leakage detection method, demonstrating that test data contamination is a pressing issue warranting further investigation by the LLM community. To spur future research, we release Skywork 13B, along with checkpoints obtained during intermediate stages of the training process. We are also releasing part of our SkyPile corpus, a collection of over 150 billion tokens of web text, which is the largest high-quality open Chinese pre-training corpus to date. We hope Skywork 13B and our open corpus will serve as a valuable open-source resource to democratize access to high-quality LLMs. TeacherLM, teaching to fish rather than giving the fish, language modeling likewise. Large language models, LLMs, exhibit impressive reasoning and data augmentation capabilities in various natural language processing, NLP tasks. However, what about small models? In this work we propose TeacherLM 7, 1B, capable of annotating relevant fundamentals, chain of thought, and common mistakes for most NLP samples, which makes annotation more than just an answer, thus allowing other models to learn why instead of just what. The TeacherLM 7, 1B model achieved a zero-shot score of 52.3 on MMLU, surpassing most models with over 100 B parameters. Even more remarkable is its data augmentation ability. Based on TeacherLM 7 1B, we augmented 58 NLP datasets and taught various student models with different parameters from OPT and Bloom series in a multitask setting. The experimental results indicate that the data augmentation provided by TeacherLM has brought significant benefits. We will release the TeacherLM series of models and augmented datasets as open source. Text-to-3D with classifier score distillation. Text-to-3D generation has made remarkable progress recently, particularly with methods based on score distillation sampling, SDS, that leverages pre-trained 2D diffusion models. While the usage of classifier-free guidance is well acknowledged to be crucial for successful optimization, it is considered an auxiliary trick rather than the most essential component. In this paper, we re-evaluate the role of classifier-free guidance in score distillation and discover a surprising finding. The guidance alone is enough for effective text-to-3D generation tasks. We name this method classifier score distillation, CSD, which can be interpreted as using an implicit classification model for generation. This new perspective reveals new insights for understanding existing techniques. We validate the effectiveness of CSD across a variety of text-to-3D tasks, including shape generation, texture synthesis, and shape editing, achieving results superior to those of state-of-the-art methods. Our project page is project's website. Atom, low-bit quantization for efficient and accurate LLM serving. The growing demand for large language models, LLMs, in applications such as content generation, intelligent chatbots, and sentiment analysis poses considerable challenges for LLM service providers. To efficiently use GPU resources and boost throughput, batching multiple requests has emerged as a popular paradigm. To further speed up batching, LLM quantization techniques reduce memory consumption and increase computing capacity. However, prevalent quantization schemes, for example 8-bit weight activation quantization, cannot fully leverage the capabilities of modern GPUs, such as 4-bit integer operators, resulting in suboptimal performance. To maximize LLMs' serving throughput, we introduce Atom, a low-bit quantization method that achieves high throughput improvements with negligible accuracy loss. Atom significantly boosts serving throughput by using low-bit operators and considerably reduces memory consumption via low-bit quantization. It attains high accuracy by applying a novel mixed precision and fine-grained quantization process. We evaluate Atom on 4-bit weight activation quantization setups in the serving context. Atom improves end-to-end throughput by up to 7.73 times compared to the FP16 and by 2.53 times compared to INT8 quantization, while maintaining the same latency target. Multimodal ChatGPT for medical applications, an experimental study of GPT-4V. In this paper, we critically evaluate the capabilities of the state-of-the-art multimodal large language model, that is, GPT-4 with Vision, GPT-4V, on visual question answering, VQA task. Our experiments thoroughly assess GPT-4V's proficiency in answering questions paired with images using both pathology and radiology datasets from 11 modalities. For example, microscopy, dermoscopy, X-ray, Connecticut, etc., and 15 objects of interests, brain, liver, lung, etc. Our datasets encompass a comprehensive range of medical inquiries, including 16 distinct question types. Throughout our evaluations, we devised textual prompts for GPT-4V, directing it to synergize visual and textual information. The experiments with accuracy score conclude that the current version of GPT-4V is not recommended for real-world diagnostics due to its unreliable and suboptimal accuracy in responding to diagnostic medical questions. In addition, we delineate 7 unique facets of GPT-4V's behavior in medical VQA, highlighting its constraints within this complex arena. The complete details of our evaluation cases are accessible at the project's website. CustomNet, zero-shot object customization with variable-viewpoints in text-to-image diffusion models. Incorporating a customized object into image generation presents an attractive feature in text-to-image generation. However, existing optimization-based and encoder-based methods are hindered by drawbacks such as time-consuming optimization, insufficient identity preservation, and a prevalent copy-pasting effect. To overcome these limitations, we introduce CustomNet, a novel object customization approach that explicitly incorporates 3D novel view synthesis capabilities into the object customization process. This integration facilitates the adjustment of spatial position relationships and viewpoints, yielding diverse outputs while effectively preserving object identity. Moreover, we introduce delicate designs to enable location control and flexible background control through textual descriptions or specific user-defined images, overcoming the limitations of existing 3D novel view synthesis methods. We further leverage a dataset construction pipeline that can better handle real-world objects and complex backgrounds. Equipped with these designs, our method facilitates zero-shot object customization without test time optimization, offering simultaneous control over the viewpoints, location, and background. As a result, our CustomNet ensures enhanced identity preservation and generates diverse, harmonious outputs.